In this lesson, we will explore and apply trigonometric concepts to solve problems involving three-dimensional figures. Now, in order to do that, we want to recall all that we've learned in this unit. So with that, if you have a three-dimensional problem, so 3D triangular problem, we want to consider all of the different ways we can solve triangles. The first one is if you're given a right angle triangle, then we can use the trigonometric ratios. SOH, remember that? Sine represents, sine theta is opposite side over the hypotenuse. Cosine theta compares the adjacent side over the hypotenuse, and tan theta compares the opposite side over adjacent. However, not all triangles are right triangles. So if we have an oblique triangle, something that is not 90 degrees, we apply the sine law or the cosine law. Keeping in mind, you can apply the sine law and cosine law to right triangles as well, but we stick with trigonometric ratios for right angles. And of course, oblique triangles, you can only apply the sine law and the cosine law. Now, the method chosen depends on the given information. You always want to start with a sketch. Having a visual in front of you with the information provided will help you decide which method used to solve the triangle. We're going to determine unknown angles using geometric facts, and we've used that time and time again. If you're given two angles, then we know we can determine the third because all the angles in a triangle have a sum of 180 degrees, the sum of a triangle theorem. Now, sometimes we have to revise the sketch if needed, meaning if, you have some information, you've calculated something, revise the sketch to reflect the information that you've solved for. We're going to also use the appropriate trigonometric methods to solve the problem. Now, how do we decide which method to use? So looking at the 3D problem decision-making tree, first look to see what type of triangles you have. If you have a right angle triangle, you're going to be using the trigonometric ratios, SOH, and keep in mind we often have to use the Pythagorean theorem to find an unknown side. If, however, you do not have a right angle triangle, then you're using sine law and cosine law, and those triangles would be either an acute triangle or an obtuse triangle. Now, with that in mind, as I mentioned earlier, in order to quickly decide which law to use, think of cosine law is if you're given all three sides or the two sides and the angle that it makes. So two sides of the contained angle, that would be cosine law. Otherwise, you're using the sine law. So let's put that into action. We have example 1. A landscaper is creating a triangular garden. The homeowner wants the garden to have two equal sides and contain an angle of 135. So let's highlight that. With two equal sides, that means isosceles triangle, and has to have an angle of 135. Also, the longest side of the garden must be exactly 5 meters. We need to determine how long is the plastic edging that the landscaper needs to surround the garden to the nearest tenth of a meter. So that would be the perimeter. So we need all the lengths. And then we're going to determine the area of the garden. So let's start with that diagram to get a little sketch of the visual. So we have to have an isosceles triangle. That means two sides are equal. Okay, we also know then that the angle has to be 135. And the largest side is always opposite largest angle. So that would be, this has to be at least 5 meters. Now, again, we know all the angles in a triangle have to equal to 180. We also know with isosceles triangles, these two angles would be the exact same. So that we can use the angle sum of a triangle theorem to figure out what those two equal angles would be. So we would say equal angles would equal to, we take the 180, we'd subtract the 135, but then we would divide it by 2 because we have two equal angles. Okay, 180, which is 45 degrees, divide that by 2, which is equal to 22.5 degrees. So those two angles in that isosceles triangle would be 22.5 degrees. Okay, so knowing that helps. Now we need to figure out the equal side lengths. Now, again, with deciding, we know it's not a right angle triangle, so we can't use the trig ratios. So we're using the sine law and the cosine law. If you look at our triangle, we are not given all three sides, and we are not given two sides in the contained angle, so automatically we would be using the sine law. So in this case, we would say, because I'm going to just call these x and they're the same, so we're going to say let x represent the unknown side length. So we're going to say x over, now it's going to be sine of 22.5 because that's the side. Then we're going to take 5, which is the length given, and the angle across from that would be sine of 135. Okay, so first things first, in order to figure out the perimeter, we need those unknown sides, those equal sides. So using the sine law, we're going to determine that. So cross multiplying sine okay, we need x by itself, so we're going to divide both sides by sine 135 degrees. Okay, keep in mind we're rounding to the nearest meter. So if we take 5 times sine of 22.5, okay, remember how I stressed to make sure you put brackets when you put into your calculators so that for the numerator and the denominator, because we're running to the nearest tenth, that would be 2.705980501. X is about 2.7 meters. Okay, so that's excellent because now we know this is 2.7 meters. This is 2.7. All right, so we're revising our diagram to include the information that we calculated. Now, the perimeter is the distance around the triangle. So in order to figure out the perimeter, which is the edging, so I'm going to just remind you, edging means the distance around, so that's the perimeter. It would be the length of all the sides. So it would be 2.7 plus 2.7 plus the given long length of 5. So adding those all up, remember we did round, so we're going to put that dot on the equal sign. So 2.7 plus 2.7, which is 5.4 plus 5, which would be 10.4 meters. Okay, so again, don't forget to answer the question. Therefore, the length of the plastic edging, and you're just rewriting the question with the answer, edging that the landscaper needs to surround the garden is about 10.4 meters. That's it. Now we need to determine the area of the garden. Now recall area is equal to base times height, divide that by 2. So in this case, we're going to have to revise our triangle because we have to break it into 2. So we would have to do such, and by doing that, this would equal to 2.7. We know that. This is equal to 22.5 degrees, and that would be the height. So we're going to say let H represent the height of the triangle, because that's the information that we're missing. We know that the base is 5. B is equal to 5. H we don't know. Okay, so in order to do that, again, because we're figuring out the height, it would be perpendicular to the ground. So I have the ability, so I'm going to get rid of the other side. Okay, so notice we have a right angle triangle. That means we're going to be using the trigonometric ratios. Now, which one? So we have to label everything properly. We know across from the 90 is my hypotenuse. There's my acute angle, would be the opposite, and then the adjacent. Okay, always remind yourself The ratio SOHCAHTOA, just a quick way of remembering which ratio compares which two sides. So in this case, we have the hypotenuse, we need the opposite. So the only ratio that has O and H in it would be sine. So we're going to be using the sine ratio in order to figure out what the height of that triangle would be. So it would be sine, the ratio, the angle, which is 22.5 degrees, is equal to the opposite side, which is H, over the hypotenuse, which is 2.7. So cross multiplying, H is equal to 2.7 times sine 22.5 degrees. H is equal to, so 2.7 times sine of 22.5, which is, if we round to the nearest tenth, would be 1.0. The value is 3, 3, 2, 4, 5, 2, 6, 7. Okay, so the height is equal to 1.0, and that would be in meters. Okay, so now that we have the height, we can figure out the area. Area is equal to base, which is 5, times my height, which is 1.0, and we're going to divide that by 2. So the area is equal to 5 times 1, divide that by 2, which is 2.5. And the units are meters squared. Remember, area is squared. Well, we're going to see. So therefore, the area of the garden is about 2.5 meters squared. Well, moving on. To determine the height of the Peace Tower on Parliament Hill in Ottawa, measurements were taken from a baseline AB. It was found that length AB is 50 meters, angle XAY is equal to 42.6, angle XAB is equal to 60 degrees, ABX angle is equal to 81.65 degrees. Calculate the height of the Peace Tower to the nearest meter. So, first of all, we want to take each of these values that have been provided and add them to our diagram. So we know AB is 50, which is great. We also know that angle XAY, so XAY, so this angle in here is 42.6 degrees. We all know XAB is 60 degrees. And we also know that ABX is 81.65 degrees. Okay, so again, we want to take all the information and then we need to know the height of the Peace Tower. Now, again, most structural buildings should be perpendicular to the ground. So that automatically tells us that we do need to use a right angle triangle, which means we can use the trig ratios. Okay, so but before that, we don't have enough information to determine the height. So we know ultimately that is our height. Or XY, we can say. I just covered that X, but there's a big X here. There we go. Okay, so we need to know ultimately the height. So it's a two-step process, right? Because we don't have enough information in that right angle triangle to ultimately solve for the height, but we do have a common side between the acute triangle on the ground as well as the right angle triangle. And AX is common on both ends. So if we can determine the length of AX using triangle ABX, and then we can use that information to determine the height of the triangle. So because this is a two-step problem, I'm just going to remind you, two-step problem. Sometimes it's nice to lay out step by step what's going on. So we're going to say step 1 in triangle. So the acute triangle AXB, determine AX Okay, and so let's see which law we would be using. So we are not given all three sides, and we're not given two sides in that contained angle. So therefore, we're using the sine law. Using. Okay, so with that, I'm going to take it apart because I like to have everything laid out separately because it gets a little confusing when you have two triangles attached to each other. So we know this is 60. We know this is 81.65 degrees. Now again, notice we're missing that one angle x. We can easily determine that knowing that all the angles in the triangle have to equal to 180. So angle x is equal to 180 minus 60 minus 81.65 degrees. So angle x is equal to 38.35 degrees. Okay, so I'm going to put that here. We needed that angle in order to use the sine law because you need the side given, you need that angle across from it. So using the sine law, we can say, I'm going to say XB, because that's the side we need, over sine of 60. Is that the side oh, we need AX. Sorry, wrong side, AX. Okay, so let's get rid of that. AX, so the angle opposite side would be sine of 81.65 is equal to, and again, we're given 50, and across from that is sine 38.35. Okay, so now cross multiplying and solving, we're going to say AX times sine of 30 is 50 times sine, sine of AX is equal to, if we took 50 times sine of 81.65, again, remember numerators, use brackets in order to avoid any kind of error, and then we divide that by the denominator, and bracket the sine of 38.5, which would be about, because we are rounding to the nearest meter, and it is a two-step process, I would probably try to keep it's 79.73065385 meters. We are rounding to the nearest meter, so that's about 80 meters. Okay, so now this is the common side in the right angle triangle, which will help us solve for the height of the piece tower. So we're going to say step 2 in triangle AXY, determine the height of the piece tower using trigonometric ratios. And remember, height is xy, that length. Trigonometric ratios. And I'm going to just remind us, toa. Okay, so let's redraw that for ourselves now with the information we have. Okay, so that is AX Y. We know that this was 80 meters. Oops. We need XY, so that's our unknown, that's the height. We also know this angle is 42.6 degrees. Okay, so before we can decide which trig ratio to use, we need to label all our sides. Across from the 90, we know is our hypotenuse. There's our acute angle. This is the opposite. And this would be the adjacent. Okay, so we need the opposite side We are provided with the adjacent side. So looking at our ratios, which ratio compares the opposite side over the adjacent side? Well, not this one because we don't have, so we know we're using TOA. So we would say 10, oops, so 10 of 42.6 degrees is equal to the opposite, which is xy, over 80 meters for the adjacent. So cross multiplying, xy is going to equal to 80 times 10 of 42.6 degrees. So 80 times 10, 42.6 degrees, and rounding to the nearest meter, xy is equal to 73.56377,103. So rounding to the nearest meter, that would be about 74 meters. So therefore, the height of the peace tower is about 74 meters. As you can tell with these problems, you do have to have a strategy in place. Come up with a plan before you start conquering the question. Okay, so looking, we have example 3. From the top of a 50-meter high bridge, 2 boats are seen at anchor. One boat X is south 50 degrees west and has an angle of depression of 38 degrees. The other boat Y is south 60 degrees east and has a 35 angle of depression. How far are the boats? Okay, so when we are looking at this, we have somebody's at the peace tower. So when we have the angle of depression, it's always from a horizontal down. Okay, so in this case, I was looking down to the boat. It would be the horizontal down. So the first, we'll call this Z, because both X and both Y. Okay, so we're looking at this angle of elevation. If this is 38 degrees, using the Z pattern, this here would also be 38 degrees. And that would be that line there. Okay, so let's connect these triangles. Okay, angle again, oops. Okay, the angle of depression as well to boat Y would be 35 degrees. So if that's 35, this is also 35. Okay, now also it says one boat axis south 50 degrees west and has an angle. So if it's south 50 degrees west, this way, that would be an angle of, what did we say, 50 degrees. So I'm going to put that in here. That would be 50 degrees. And the other one is south 60 degrees east, so that would be 60 here. Okay, so with that in mind, we can add these together to get the full angle measure. Now the full angle measure, 50 plus 60, would be 110 degrees. Okay, our ultimate goal is to figure out the distance between how far are the boats. So the distance x, y. So we can say let xy represent the distance between the boats. Okay, so how do we go about that's our ultimate goal, is to figure out that distance. Now, we don't obviously have enough information in that obtuse triangle because we only have one angle. So that's not going to help us. What we can do, however, because we do have that the top of the 50-meter bridge. So that means that we know that the height of the tower would be 50 meters. Okay, so that information helps us. Now, Again, most of these structures should be perpendicular to the ground. So what that tells us, if there's a 90-degree angle, we can use trigonometric ratios. So what we need to do is notice they have the common sides here, here. Now, in order to identify this is the base of the bridge, I'm going to call this B, just to make it easier. Mhm. That makes it easier. Now, if you're looking at those two triangles, those are two right angle triangles. So we do have the height of the tower there. Okay, so top of the high bridge. Okay, that is a 50-meter distance. So we do have that height, which will help us. So now what I think we should do is use trig ratios in order to solve those common sides, and then use those common sides in the obtuse triangle in order to solve the unknown, which is that distance between x and y. So let's start. Step one, we're going to say, step one, in triangles, I'm going to say x, b, z, and triangles x, y, b, z. Find the length of x, b, and xy using trigonometric ratios. Because it's a right angle triangle in both of them. Trigonometric ratios, which again is SOHCAHTOA. Okay. Okay, let's start with the first triangle. So in triangle X, B, Z, I'm going to draw that out for myself. We know this is 50 meters. We know this is 38 degrees. We know it should be perpendicular. So it'd be X, B, and Z. Okay, so labeling everything we have. Across from the 90 is my hypotenuse. There's my acute angle across, and this is my adjacent. Okay, now because we need XB, that is what our unknown is. We are given the opposite. Which ratio compares the opposite side and the adjacent side? Well, in this case, definitely not these two because sine and cos both need hypotenuse. So we're left with TOA. So we're going to say 10, 38 degrees is equal to 50 over XB. So cross multiplying, XB is going to equal to no, sorry, XB, I apologize, XB times 1038 is equal to 50. We need XB by itself. We're going to divide both by 10 to 38. XB is equal to 50 divided by 10 of 38. Okay, and I think we have to round to the nearest meter. So this is 63.9970816. So XB is about 64 meters. Once they're doing the exact same thing again, it's always great to have that visual. So it'd be B, Y, Z. And this time the angle of elevation happens to be 35 because the angle of depression was 35. And the height here we know is 50 meters. And we need XY. So in triangle X, B, no, Z, not X, ZB, yeah, ZBY, ZBY. Again, we want to label. So this is going to be hypotenuse, opposite, and this would be adjacent. So again, we need the adjacent, and we need we're given the opposite. Oh, I noticed that when I wrote this, it should be BY. XY, that should be BY. Okay, now again, the order BYYB doesn't really matter, but we do want to identify the right side. Okay, so then tan again, we're using because we are given opposite and adjacent. We're given the opposite side, we need the adjacent side. So 10, we're going to say 10 at 35 degrees is equal to the opposite, which is 50 over VY, cross multiplying. VY times 10, 35 degrees is equal to 50. Divide both sides by 10. Vy is equal to 50 divided by 10 is 71.4074. We're going to say By is about 71 meters. Okay, almost there. So we got to the two lengths. So now if we look at step 2, we're now going to use either the sine law or cosine law to determine the unknown. So in triangle X, B, Y, and determine X, Y, or its cross. So let's see what information we have and what information we need. Okay, so we've now determined X, B, and Y. So we knew this is 110 degrees. We know that this was calculated to be 64 meters, and this was calculated to be 71 meters. Okay, so if we look here, we have two sides and the angle that those two sides make. So two sides of the contained angle, and we learned if we have that information, then we can easily use the cosine law. Okay, so XY, now because that's B might be easier, and let's just go up and I modify that. Let XY, or let's say B, represent the distance between the boats. Okay, so we're going to determine XY using the cosine law. Again, because we were given the two sides of the contained angle. So we're going to say B squared is equal to 64 squared plus 71 squared minus 2 times 64 times 71 times the cosine of that angle 110 degrees. So taking 64 squared plus 71 squared minus 2 times 64 times 71 cos of 110 would be about B squared equals to 12,245.27906. And of course, we need to get rid of the square, so we square root both sides. And we are left with B is equal to 110.658389. Surrounded, B is approximately 111 meters. Therefore, how far are the boats? Therefore, the boats are about 111 meters apart.